Welcome to the BDB Platform 11.0 overview. In this video, we will walk through the major capabilities introduced and enhanced in BDB Platform 11.0. BDB Platform 11.0 brings together observability, semantic governance, data engineering, data science, analytics, AI agents, operational applications, observability, and satellite apps into one unified platform. This release is organized around four key areas: developer assist with observability, Kinetic Semantic Layer, modernized data engineering, and satellite apps. Let's begin with the platform homepage. This is the BDB Platform homepage. From here, users can access different platform modules based on their role and permissions. Business users can work with dashboards, reports, data agent, and operational applications. Data engineers can work with data center, data pipeline, jobs, and lakehouse assets. Data scientists can use Data Science Lab for notebooks, machine learning, and distributed execution. Administrators can manage users, roles, permissions, workspaces, and governance settings. The key idea is that all these users work in one governed enterprise platform. BDB Platform 11.0 includes improvements in the platform core. One of the major additions is the BDB Proactive Monitoring Dashboard. This dashboard provides a centralized troubleshooting surface for jobs, pipelines, and platform components. It consumes structured diagnostic logs, lifecycle events, and failure classifications from different components. This helps teams perform faster root cause analysis and detect anomalies earlier. The platform also includes a refreshed widget user interface and security hardening based on penetration test remediations. Next, let us move to Data Center. Data Center is the central place to manage enterprise data assets. Here, users can manage connectors, data stores, lakehouse assets, data quality rules, and satellite apps. In BDB Platform 11.0, Data Center becomes more powerful with the addition of the native Data Lakehouse, satellite apps, dynamic form framework, and enhanced data quality monitoring. This makes Data Center the operational hub for managing data assets across the platform. One of the important features in BDB Platform 11.0 is the native Data Lakehouse. The Data Lakehouse is built on Apache Hudi. It supports ACID tables, schema evolution, upserts, deletes, and time travel queries. Users can create and manage Lakehouse databases and tables directly from the platform interface. There is no need to use a separate external administration console or manually write DDL for basic provisioning. The Lakehouse is Data Center native, which means it inherits connectivity, lifecycle management, governance, access policies, and data quality rules. Lakehouse tables are also accessible from data engineering pipelines, Spark jobs, and Data Science Lab notebooks. Now let us look at one of the most important capabilities of BDB Platform 11.0, the Kinetic Semantic Layer. In this release, the data catalog has been upgraded into a full semantic layer. The semantic layer combines ontology, metrics, quality, stewardship, classification, entitlement, and lineage in one governance surface. Instead of working only with raw tables and columns, users can model enterprise concepts as business objects. Examples of business objects include product, inventory position, cost of poor quality, and demand forecast and customer, etc. Each business object can have properties, relationships, and derived measures. This helps the platform represent data in business terms rather than only technical schema terms. The semantic layer also includes governance capabilities such as data quality, classification, stewardship, entitlement, and lineage. Assets can also be classified as public, internal, confidential, or PII. Data quality rules can be defined, executed, and monitored against catalog assets. The results appear as trust scores on asset pages. These classification tags help support discovery, entitlement, and quality workflows. The platform also provides end-to-end lineage. Lineage captures relationships across datasets, pipelines, Spark jobs, metrics, and business objects. This helps users understand where data came from, how it was transformed, and what downstream assets may be impacted by a change. Next, let us move to data pipeline. Data pipeline is used to design and run data ingestion, validation, transformation, and movement workflows. Let me start with one of the most powerful capabilities introduced in BDB Data Pipeline 11.0, Job AI Assist. Traditionally, building data pipelines requires manual effort, selecting components, configuring logic, and designing workflows step by step. With Job AI Assist, BDB transforms this completely. Now, users can simply describe their requirement in natural language, and the platform automatically generates a complete pipeline. As you can see here, the user provides an input, and BDB understands the intent, and builds the entire workflow including data readers, transformations, and writers. It also performs intelligent component selection, choosing the best components and configurations based on the use case. In addition, the system applies built-in validation and optimization, ensuring that the pipeline is reliable even before execution. This significantly reduces development time and enables teams to go from idea to execution much faster. Overall, Job AI Assist makes pipeline creation intelligent, automated, and accessible to both technical and non-technical users. From requirement to pipeline, in seconds, powered by AI. Once the pipeline is generated using AI Assist, the next key capability is how BDB handles data movement across systems using the Data Lakehouse. BDB provides native reader and writer components that are fully integrated into the pipeline. The reader component allows us to read data from the Data Lakehouse and also combine it with data from other sources for processing. On the other hand, the writer component enables us to write processed data back into the Data Lakehouse or even push it to other destination systems. So essentially, BDB supports bidirectional data movement. From the Lakehouse to any system, and from any system back into the Lakehouse. As you can see in the UI, this is achieved using a simple drag-and-drop pipeline design, making it very intuitive to build and modify pipelines. This enables a complete end-to-end data flow, where the Lakehouse acts as both a central source and a destination for all data operations. Now let's look at how BDB ensures data quality within pipelines. The Python schema validator validates incoming data against a schema definition, such as a JSON schema, before it moves any further. Strict mode checks for exact field, type, and structure alignment. Any record that fails is automatically separated into a dedicated error stream, so the main pipeline keeps running without disruption. This catches issues early, reduces downstream failures, and supports custom Python logic for complex validation scenarios. Direct hit, clean data in, reliable outcomes out. Now let's look at how BDB enables real-time, API-driven execution of pipelines through on-demand job as an API. In many scenarios, jobs need to be triggered dynamically by external systems rather than through schedules or manual actions. With this capability, BDB allows us to expose on-demand jobs as APIs, making them accessible programmatically. As you can see here, each job can be invoked using an API endpoint along with the required authentication details. This enables external applications, services, or workflows to trigger job execution in real time, without needing direct access to the platform. It also allows jobs to be reused as standardized execution services, ensuring consistency across multiple integrations. Overall, this feature extends pipelines beyond the platform, enabling flexible, scalable, and API-driven execution. Trigger pipelines anytime, anywhere, through simple API calls. Let's now explore how BDB enables efficient incremental data processing through its offset mapping capability. In large-scale data pipelines, processing the entire dataset repeatedly is both time-consuming and resource-intensive. Offset mapping solves this by enabling precise tracking of processed records using offset values. Instead of reprocessing everything, BDB processes only new or changed data, significantly reducing execution time and compute usage. It also maintains continuity between source data and pipeline execution state, ensuring a consistent flow across ingestion stages. In case of failures or restarts, the system can resume from the last processed offset, avoiding unnecessary reprocessing. Overall, this improves pipeline efficiency, reduces duplication, and ensures reliable data movement, especially for high-volume and continuously changing datasets. Process only what's new, faster, smarter, and more efficient. Let's now look at how BDB enables intelligent pipeline orchestration using the trigger component. Instead of relying on external schedulers, BDB provides a built-in trigger mechanism directly within the pipeline. As you can see here, the trigger acts as the starting point of execution, allowing pipelines to be initiated automatically based on defined conditions. One key capability is pipeline-to-pipeline triggering, where the completion of one pipeline can automatically initiate another. This helps in building dependency-driven workflows without manual intervention. In addition, BDB supports event-driven activation, enabling pipelines to respond dynamically to events such as data arrival or system signals. This makes the entire workflow more responsive and automated. Overall, the trigger component provides fine control over execution flow, enabling users to design pipelines that are not just connected, but intelligently orchestrated. Now let's look at how BDB ensures secure and controlled access to data lake tables and Spark workloads using role-based access control. In a shared data environment, multiple users and teams need access to the same data assets. To manage this effectively, BDB provides role-based permissions at the data lake table level. As shown here, access can be granted to individual users or user groups, making it easy to manage permissions at scale. We can assign specific privileges such as view, insert, update, delete, and drop, depending on the role and responsibility of the user. This ensures that users only have access to the data and operations they are authorized for, maintaining strict control over sensitive data. It also enables centralized governance, where all permissions are managed from a single interface, ensuring consistency and compliance. Now let's look at how BDB enables distributed execution for advanced workloads using RayJobs. Unlike traditional execution models, Ray allows tasks to run in parallel across multiple workers and nodes, making it ideal for compute-intensive operations. With Ray, BDB supports Python-native workloads, meaning existing Python code can be scaled without major changes. As workloads grow, Ray distributes tasks dynamically, enabling multi-node parallelism for faster execution, whether it's batch processing, simulations, or machine learning models. It also provides elastic resource utilization, where compute resources such as CPU and memory are used efficiently based on demand. This ensures that workloads can scale up or down seamlessly without manual intervention. Overall, RayJobs bring together data processing and AI workloads into a unified distributed framework, enabling faster and more efficient execution at scale. Next, let us look at Data Science Lab. Data Science Lab provides a workspace for notebooks, machine learning, experiments, and distributed execution. Let's begin with the first feature of BDB DSLab 11.0, RayJob. RayJob enables distributed execution in DSLab, allowing workloads to run across multiple worker nodes instead of a single machine, improving speed and efficiency. It automatically splits tasks and executes them in parallel across workers, ensuring optimal resource utilization. Each worker processes data or trains models independently, significantly reducing overall computation time. Once execution is complete, results are aggregated centrally for unified analysis. With built-in fault tolerance and horizontal scalability, workloads can scale seamlessly as demand increases without changing core logic. Now let's see how RayJob is configured within BDB DSLab. We start by creating a new project in DSLab, where we define the project name, environment, and resource allocation. We also have the option to configure external libraries, Git integration, and execution environment for flexibility. To enable distributed execution, we simply activate the Ray option. This prepares the environment for parallel and distributed execution across the cluster. Once Ray is enabled, we can configure the RayJobs setup. The head node manages scheduling and aggregation, while worker nodes perform the actual computation. We define CPU, memory, replicas, and scaling limits. This configuration allows the system to dynamically scale based on workload demand. We can increase workers to handle larger datasets efficiently. Now let's look at the widgets capability in BDB DSLab. Widgets allow users to directly access and interact with datasets inside the notebook environment in a structured and reusable way. Using the widget executor, we can fetch dataset data dynamically by passing parameters such as dataset ID, user context, filters, and transformations. This makes data access consistent, governed, and parameter-driven, without needing manual queries or external connections. Once the data is loaded through widgets, we can preview it instantly within the notebook. This helps in quick validation, exploration, and preparation before applying any transformations or models. Widgets also integrate seamlessly with visualization capabilities. Users can directly create charts by selecting chart types, defining axes, and configuring properties, enabling fast visual analysis. Now, let's explore the data science agent in BDB DSLab, your AI assistant for faster, smarter data science workflows. The data science agent acts as an AI-powered assistant embedded directly within the notebook environment, helping users accelerate end-to-end data science workflows. Here, the agent understands the user's requirement and automatically analyzes the existing code, suggesting an improved and structured version, such as combining training and model-saving logic into a clean, reusable function. Instead of manually refining code, the agent can generate optimized, production-ready implementations with best practices, proper structuring, and clear documentation. It can also leverage additional context to enhance the workflow, suggesting better approaches, improving code efficiency, and ensuring alignment with platform standards. This significantly reduces manual effort and speeds up development cycles. Users can interact with the agent conversationally, refine outputs, and directly execute the generated code within the same notebook environment. With Data Science Agent, BDB DSLab transforms traditional coding into an assisted, intelligent workflow, enabling faster experimentation, better code quality, and smarter model development. Now let's look at another key feature in BDB DSLab 11.0. We have added native readers and writers for S3, GCS, and Azure in the PySpark environment. This enables users to directly read and write data across multiple cloud storage platforms without relying on external connectors or custom integrations. With this, PySpark jobs can seamlessly access multi-cloud data. Users can work with data from different cloud sources using a unified interface, simplifying development and reducing complexity. At the same time, access remains secure and governed, aligned with platform-level authentication and permissions. This also improves performance for large-scale data processing. PySpark can efficiently process high-volume datasets across cloud environments, making it ideal for enterprise-scale workloads. Overall, this feature simplifies multi-cloud data handling and accelerates data engineering and data science workflows within BDB DSLab. Now let's look at the model versioning capability. In DSLab, every time we train and save a model, it is automatically stored as a new version under the same model name. Here on the left, we can see multiple versions of the model being maintained, each representing a different experiment or training run. During the process, we log important metrics such as accuracy, precision, recall, and F1 score, along with parameters and other metadata. Once we execute the Save Model step, a new version is created automatically. This ensures that every experiment is captured with its complete context, including inputs, configurations, and performance results. Users can easily track changes across versions, compare results, and identify the best performing model. We can also load any specific version or simply use the latest version for further analysis or deployment. BDB Platform 11.0 also includes the BDB Assist Agent across development surfaces. In Jobs, BDB Assist Agent supports job authoring, configuration validation, and troubleshooting recommendations. In Data Science Lab notebooks, it supports notebook authoring, code completion, and troubleshooting. In data quality, it helps with AI-assisted rule authoring. This reduces manual effort and helps users configure, validate, and troubleshoot platform workflows more efficiently. Now let us move to Data Agent. With BDB Platform 11.0, data agents are grounded in the semantic layer. This means they reason over business objects, governed metrics, classification tags, and data quality signals, rather than relying only on raw database schemas. So when a user asks, "What is our inventory turnover performance across categories and locations?" the agent understands the business meaning, identifies the right metric definition, and applies the correct category and location dimensions. This helps reduce hallucinated joins, misread columns, and inconsistent metric calculations. The release also introduces an agent evaluation framework, which helps measure agent performance, response quality, and behavioral consistency over time. Overall, Data Agent enables users to ask business questions naturally and receive trusted, governed answers. Next, we will explore one of the most important capabilities introduced in BDB Platform 11.0, satellite apps. One platform. Unlimited apps. Zero hallucination. The Kinetic Semantic Layer becomes the governed intelligence foundation for the enterprise, powering dashboards, AI agents, APIs, and operational applications from one shared semantic model. Instead of building disconnected applications with duplicated business logic and infrastructure, organizations can rapidly build satellite apps directly on top of the BDB platform. These satellite apps can be developed using AI coding tools such as Claude Code, OpenAI Codex, or Cursor AI, helping teams move from idea to production-ready applications in days instead of months. Because the apps inherit authentication, RBAC, semantic models, audit trails, connectors, and governance directly from the platform, developers do not need to rebuild back-end services repeatedly. To demonstrate this concept, let's look at one example, the BDB Inventory Command Center. This satellite app is built for inventory and supply chain operations and is powered entirely by the Kinetic Semantic Layer using governed business objects and trusted business metrics. The application allows inventory managers to monitor stock health, manage replenishment, optimize transfers, track supplier performance, analyze quality incidents, and execute operational workflows from one unified workspace. We also integrated the Retail Intelligence Agent, allowing users to ask natural language operational questions directly against governed enterprise data. Thank you for exploring BDB Platform 11.0 with us. Today, we showcased how BDB brings together semantic governance, AI agents, data engineering, analytics, data science, operational applications, and observability into one unified platform. From the Kinetic Semantic Layer and satellite apps to AI-powered operational workflows, BDB 11.0 enables organizations to rapidly build intelligent, governed enterprise applications. One platform. Unlimited apps. Zero hallucination. Thank you.